there's any doubts are there, we'll clear it out. Okay, right. Now we are going to see now we are going to see OSPF. Today's topic is OSPF. Now,
again this started.
Yes, today this started. 2 days it was rest. So we'll start the OSPF. Now OSPF, the concepts are divided into two parts: single area, multi area. So let us start from OSPF first. First, OSPF is a link state routing protocol. What is link state routing protocol, Yogesh? What is link state routing protocol? The three types of routing protocols are there, right? Distance vector, link state, hybrid. What is link state routing protocol?
So routing by road map.
So what do you mean by that?
So if you see the road map for the routing.
What is road map?
Topology, complete topology.
So if you understand the complete topology of the network, then it will find the best route. It will not ask routes from the neighbors. So from neighbors, it will not get any updates. Understand? So it will only get the topology details from the neighbor. Then after that gets the topology, it will find the best route himself. Okay. Now, OSPF means what? Open shortest path first. Right? So it, as I told you, the updates what is given by neighbor is what? Only the state of the link. So now you have your topology. I am going to send the update. See, in your topology, I told you that I have connected to 10 dot network, right? In this interface, that is down. Like I will tell you, I will give update, but I will not say what is this next station, this is the best route. I will not give like the next hop now. What I will say is the update is simple. I will say in the I gave a topology for this information for you. Like in this topology, I am connected to 10 dot network FA0/0, that is down. Or newly one interface added. It is having 10 dot network up. So only the state of the link up down. Link state I will give update. I will not say to go to this network, this is the best route like that. But what RIP-AGRP will do? RIP-AGRP, what it will do? It will tell you want to go to 20 dot, this is the best, this is the route, like that. It will give the next hop IP address, exit interface. So you saw a RIP update. I said I showed you, right? It has two routes, right? Like that. So that is RIP and AGRP will do. But OSPF is only giving the topology link state. This link is up, this link is down. Link state update. Like FM radio, no, they say this road is traffic. Don't take this road. Everybody know Bangalore map. What they will say is this link, this road is traffic. This road is like that. They give the state of the link, the road. Understand? This is a classless routing protocol. It supports CADR VLSM. It's an interior gateway protocol within say one autonomous system. Algorithm is SPF or discharge. Metric is 100 divided by bandwidth in Mbps. We saw this metric. Terminology. Now I am going to teach you the, like how we study the FD, AD, passive route, active route, successor feasibility condition. Like we studied like terminologies for EAGRP. OSPF also have terminologies. Right? That I am going to teach you. So let us start. Now, as I told you, OSPF is developed for what? Developed for bigger networks, very big networks, right? So when you go for bigger networks, you have to maintain some hierarchy. Hierarchy means like CEO, manager, employee, like hierarchy. So employee will report to manager, manager will report to CEO. Like that, head office, state office, branch office, like that they keep. For whole India, Delhi is the head office. For every state, one state office, like Bangalore is Karnataka state office. Then every branch, every city will have a branch office, like that. So they are divided the hierarchy. There is some hierarchy, right? So when you maintain this hierarchy, like what we will do in in OSPF, what we will do, we'll create something called areas. First terminology is called what? Areas. Okay, now I'm going to create an area. This is my area 0, or backbone area, and I'll create one more area. Right, this is one area. I'll create another area. Yeah. This is one area. So now we have three types of areas, right? Now these three types of area, R1, for example, I'm giving name R2, R3, R4, R5. The first terminology, what I'm going to discuss is area. So what is the benefit of area? What's the benefit of area? They gave two benefits. One is summarization. What is summarization? Second is fault containment. In OSPF, we create areas. So this is for easy management. So the benefits of areas are summarization and the fault containment. Now first point, summarization. What is summarization? Let me explain you this. Now we have like this, one more, like this, one more. So this is 10.1.1.0/24. This is 2.0/24. This is 3. Like that, 30 branches are there. 30.0/24. Understand? Now, head office will get how many routes? 30 routes. If I give show IP route, I'll get here how many routes? Show IP route? 30 routes. Now here in R2, I will do something called summarization. So what is summarization? I will see what is the common value in this 10, 10, 10. I will tell this head office, this of sending 30 routes, right? I was sending how many routes? 30 routes, 10.1.1.0, 10.1.2.0 like that. I will do summarization in R2 and I will say, instead of 30 routes, I will send only one route. How I will say? See, I will send one route. What I will say? Anybody who wants to go 10 dot network, please send to me. Who will tell this? R2. R2 is telling to R1, Whoever wants to go to 10 dot network, please send to me. Now show I prove if I give how many routes will be there.
Only one.
It was 30 routes. I am telling one state. Think like Karnataka, Tamil Nadu, Kerala, right? Every state will have hundreds of branches. So every branch, one network will be there. So all network address, if you send to the head office, what will happen? Head office routing table, like thousands of routes will be there.
Yes.
So if you do summarization like this, every state at state level, state router, then you will have only 25 branches, means 25 routes will be there.
Yes.
25 states if you are maintaining all over the India, 25 routes will be there in the head office. So every state office if you go, you will see their branches which is directly connected. That branch it will be there. Understand? So this is the one benefit of area.
Yeah.
So one route will become 32 one route, right? This is summarization. What I am teaching here. You just draw this diagram. This diagram you will draw.
Yes.
This part. You are understanding, Mallikarjun?
Yes, sir. Suppose if you are having 10.1.1.0 to 10.1.30.0, sir. 30. So it will send 10.1.
10.0.0.0/8.
So all zeros, sir.
All
Even-
tens.
Because here.
What I am saying is anybody starts from 10. Please send it to me.
Okay. But here common number is 10.1.
Can you 10.1 also? Just saying 10. Tomorrow you may add 10.2 also, 10.3 also. In future, no?
Yes.
After 255, what you will do?
Next 10.2.
10.1.2, you go 255 branches happen. 256 branches starts.
10.2.
See, in Karnataka, there are so many branches are there.
Yes.
Okay, ICICI Bank you take. How many branches will be there?
So
So, you keep it 10 further. So, all 10 goes. Clear, na?
yes.
If there are different networks, then it will send different routes.
Which one? No, you have to design like this.
If there
You have to design the IP address like this. You cannot give 10 and 182, 168 and 142 like that. You cannot do that. So Jayanagar means Jayanagar only. You cannot keep Jayanagar next to building, next house is JP Nagar, next house is Malleshwaram. In one street you cannot give 3 area. Whole street has to be single area. Correct, na?
Yes.
And only you can say this area first you go. In that area first you go to that sector, and that sector you go to that main. Go to that main. After that main, go to that particular door number. Otherwise, you cannot do it. No? Addressing has to be proper. Clear on this?
Yes.
Okay. First, what I taught you is summarization. Next point is fault containment. What do you mean by fault containment? Fault containment means, now for example, this route failed. this route failed, right? I will send this to everyone. This guy, here, 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 everyone. So this is unnecessary. People are getting information. I don't want everybody to get. For example, thousands of routers are there. All 1,000 routers will not get that the fail up down status. So instead of that, what area will do is area will only say whichever their area no, that routers will get the update. That's it. The fault is contained within the area.
Yes.
What is the benefit? Unnecessary others are not getting updated. For example, this guy wants to go to this R6 like this. This is R6. You want to go here. This guy will say, sorry sir, R6 is not available. He will give the reply. Understand, no? So because he is updated, right? This is one to reduce the updates. All flooding. We say update flooding. Flooding will be reduced. Flooding domain. Area is called what? The flooding happens only within that area. Like broadcast domain, we know. Same way, updates will go only in the within the one area. It will not go to other area.
So here it will update to R2. That's it. Here it will update to R2.
R2 will affect everything.
Not R2. See, R2 failed. R2 knows it is failed. Now R2 has to update. Whom he will update?
All the 30.
All the area, that area. For example, I'll give name, number I'll give you. Area 0, area 10, area 20. Now what he will do, R2 will do is, R2 will give updates to only area 10 routers.
Okay.
So this is area 10 issue, so this is updated only to area 10. This is flooded. The update is flooded to only the
Area 10.
area 10. The first. So what it is flooding? The flooding is update is called what in OSPF terminology? LSA. What is LSA? Link state advertisements. Link state advertisement. Right? Now, third state. Third condition is, now this link state advertisements are there, right? Now there is one area called area 0. That is called the backbone area. What area?
Backbone.
Where all areas are connected. All areas are connected. Meaning area 10, area 20, how many areas you create, all areas has to connect where?
Backbone.
Backbone area. So which is area 0 is backbone area. Other area. This install is called what? Other areas. Area 10, area 20. Now, every area will have one router. That is called area border router. ABR. ABR. Area border router. So what is this area border router? What is area border router?
One which is connected to that particular area to all the servers.
One interface is connected to backbone area and other interface connects to other area. So what is area border? How do you define area border router? One interface connected to area 0. Area 0 is what?
Backbone.
Backbone area, and other interface connected to other areas. Okay, now example ABR, R2 is ABR for which area? In this topology, R2. ABR for which area?
Area 10.
R3?
Area 20.
Understand? So one interface connected to area 0, another interface connected to other area. So that area, it will become a backbone, ABR. ABR means area border router. Now, next is ASBR. What is ASBR? Autonomous System Boundary Router. Autonomous System Boundary Router. So what is this? This is the router, one interface connected to other area and the other interface connected to DIP, EGRP, internet. So let us take this R1. I'll show you this. Now there is a, it may be anything, any network. It may be RIP, EGRP, internet. Okay, it is connected. So R1 is connecting out of OSPF. It is going somewhere out from OSPF. So that is called what? That router is called what? ASPR. Understand?
Could be connected to other OSPF or something.
That will be other area. No? Area.
Another area.
Area. It's OSPF. It's not autonomous system.
Not one that.
Autonomous is something going out of OSPF. If you're going to OSPF, some other OSPF, then it become other area or backbone router. Or other area or backbone router? Backbone area, correct.
Other backbone area we can.
Other backbone, how can it become other backbone area? Delhi is the capital of the Bangalore, India. Right? Other capital will come for him. In India, how many capitals should be there? India's capital. Design part, yeah. Designing, na. In India, how many capitals should be there? All are connected to Delhi or not? Whatever big decisions has to go to Delhi or not? All states has to go to Delhi for central problem, central government. And you have another capital. You understand? So when there is external affairs, right? External affairs means what? Other country.
Other country.
So there is a one connectivity, right? So that is only from Delhi only, right? Everywhere we cannot start doing external affairs, no? That is ASBR. So only one capital, from the one capital, one guy will go as a minister, external affairs minister. He will go and bring outside things.
Yes.
Right? He has connectivity or something. Understand? So you will say two capital will be there. Then you are confused. You cannot run a government. Design mistake. See, there are three things. One is design issue, implementation issue, protocol issue, implementation issue. So design itself is wrong means implementation and other things will not happen. This is basically to understand the design. How you design a OSPF network. Clear? Any doubt?
I was thinking like
we have India and Delhi as capital, and we have Sri Lanka.
That is another autonomous system.
Okay.
To connect these
So
two
it's-
autonomous system, you need a BGP. Connect these two autonomous system. It is OSPF, this is OSPF. To connect these two, you cannot directly connect. You need the internet for that.
That was
You need the internet, no? That is why I am connecting here.
That was my
The internet is the point. You cannot directly connect. Another OS, another network you are going, OSPF or any network. How do you go?
to internet.
Within your company, you are going.
Directly.
This is see within your company. This may be Delhi. This may be Sri Lanka. This may be Sri Lanka. This may be Malaysia. You understand this?
Understood.
ASB R1 is India. R3 is Sri Lanka. R2 is intranet. If you are running intranet, R1, R2 is what? R1 is India, R2 is Sri Lanka. In Sri Lanka, how many branches you have? That will be connected to the branch office. R1 is India, R3 is Malaysia. In Malaysia, 10 branch office, 10 branch office. But all are running in single OSPF. This is, you are talking world level. But still, if you want to go to another company, then you need a internet connection. Or you have to do redistribution. So many things are there. Internet connection, or if it is other protocols like this, you can go for redistribution. Understand? So here what I am teaching is, think like this. See, it's a logical boundary, right?
This I got.
No, this is a logical boundary. I am giving you the example for logical boundary. Think like that whenever you are going outside of OSPF. Now your design part. Tell me your design. I'll explain you. You tell me what is your design now. You tell me the design part. Your company.
Two different OSPF.
You are starting with wrong. You tell me what is your requirement. I'll tell you the design part.
No, that I clear.
No, you tell me your design. Tell me your requirement. What is your company? Where are the branches are there?
Okay, one company is ICICI Bank and another is HDFC.
That is different. You tell about your branch, your company. ICICI, I'm not worried about the two. That is connecting to other. Then you need a service provider. That is different. My question is within your company. You tell me how many branches you have.
We have 10 branches.
In all over the India or simply?
All over India.
So then you use this method. India head office, Delhi head office, state office, branch office. This is the hierarchy. Now you want to connect outside of your company, other company, then you need a service provider. That is internet I mentioned. That I mentioned internet, right? Intranet, extranet, intranet. That all are other service. You are going outside service provider. Through internet you can go, or you can go through extranet also. Extranet is different companies. You know, like intranet means within your company. Extranet means what?
Two different companies.
So that is extranet. For that also you need a
Service provider.
right? Correct? So for that also you are connecting to the service provider. So service provider is again you are going outside of your OSPF. You are not connecting with another OSPF. Then after that the other company, he may have anything. I don't know what he is having. It is something like your other company. So what he may have? He may have static, right? RIP, PHARP, OSPF, anything. Doesn't matter. But I am not connecting directly. No, I know I am connecting. I am connecting through a WAN service provider. You able to understand this?
Understand.
Suppose there are 5 branches, existing branches, sir. They are using OSPF well and fine. Now they are building another 5 new branches and they want to use PHARP. And they,
Why?
their company
You are
design-
speaking.
Yes.
You are speaking Tamil.
Yes.
Suddenly you want to say 5 branches to speak official language Malayalam. Why?
Is it possible?
No, why? Possible. Why?
They might have found some advantages of PHARP.
What
That's
advantage?
suitable for their network.
What advantage? It's a design problem, no?
Yes, yes.
It's a design issue. We can do it. That is called redistribution.
Redistribution.
Not like that, it will not come. Your scenario is wrong. I'll tell you the scenario where it comes. This issue will come, but not like when you're designing, you'll go for another protocol. You will not go like that. Then you are wrong. You are designed wrong. It does not agree for you. When this issue will come is you are hiring one company. That company is running EAGRP.
Yes.
You are running
You are
OSPF. You are acquiring one company,
Yes.
right? Not new branches. You are acquiring some branches from other companies.
Yes.
They are running EAGRP. Now suddenly you cannot change everything to OSPF there.
Yes.
So how do you connect with them?
Yes.
That time we do redistribution.
Redistribution.
That topic is coming next topic. Okay, not new branches. New branches you have to go for the same protocol.
Same.
If the protocol is not supporting, for example, EAGRP is not supporting after 255, it will not support 255 nodes. No, if some issue is coming EAGRP, you want to move everything. You have to move to OSPF.
OSPF.
Right? You cannot say half OSPF, half EAGRP. Then it is a problem for you only to manage. The only situation will come is new branches. If you are new companies you are acquiring, that time they will be having again EAGRP. Meanwhile, just a temporary solution, you can do redistribution. But permanently you want to change that also, you have to change that also to OSPF.
OSPF.
But when you buy itself, you cannot change it, no? Take water. Okay. Now,
They just explain that internet extranet and intranet.
Mhm.
Is the
what is that?
internet extranet and intranet.
What is internet, intranet? Internet is right. Okay. Internet is public WAN. Public WAN. Extranet is private WAN, different organizations. Intranet is private WAN, same organization. So internet is what?
Public
Public WAN. Intranet is private WAN.
private.
Extranet also private WAN. But the difference is same organization. If you do WAN connectivity, that is.
Intranet.
So even you buy branch branch connectivity, no, you cannot do yourself. You have to go to service provider only. Delhi to Bangalore, how do you connect? You can connect and bring your own cable. No, you have to go to a service provider. That connectivity, what they call, service providers calls is intranet.
Intranet.
Now you are connecting from one company to another company. That connectivity they call it as extranet. This is intranet. Clear? Any doubts?
No.
Okay. Next topic we are going to study is router ID. In OSPF, we are going to understand something called router ID. So what is router ID? Name of the router, name of the router, where for OSPF processes. Router ID. What is the format? Format of the address is IPv4 address. IPv4 address format. Example. R1 you can give name like this 1.1.1.1, and R2 you can give name like this 2.2.2.2. It has to be unique, it cannot be same. Right? Name of the router. So how to configure this? Configure automatically. It will configure. In order to give any command for this, first it will do highest IP address, highest uplink interface IP, second stage highest loopback interface IP, third manually we can do it. Manually we can use a command called router ID command. You can use this command and change whatever IP address, whatever name you want, you can use it. So for example, you have three interfaces in a router. One is 10 dot, one is 192 dot, one is 1 dot. Like this. In a router, we have three interfaces. FA0/0, S0, loopback interface 0. Loopback, you know what is loopback? It's an interface, virtual interface for self-testing purpose. So here I give 182 dot, here I give 10 dot, here I give 1 dot. Which one? 1 dot, 1 dot, 1 dot, 1. So which one will become the router ID? Automatically, auto.
Yes, 192.
192 if it is highest IP address, but it will override with the
Yes,
loopback IP address. So loopback IP address is how much?
1.1.1.
So that will become your router ID. Why loopback is more priority than physical interface? Because physical interface can go down and up.
Yes.
But loopback interface will be always up. So virtual interface. So that name is good, safe then, because some reason that interface went down, right? They cannot communicate with the router. So better we go for loopback interface IP address. The name of the router. So what is the name of this R1 router? OSPF language 1.1.1. Whenever OSPF is speaking, it will say that packet is coming from 1.1.1.1. 1.1.1 will become neighbor. So he used that name for OSPF communication. Understand router ID? Okay. Next, any doubt? Okay. Next, I'm going to teach you DR, VDR. Seventh terminology, DR. Loopback, I told you. What is loopback?
Self-test virtual.
It's a virtual interface, not a physical interface.
User for self-test.
Virtual interface used for self-testing. Then eighth, tell me, 8. Next, we'll use DR. You told DR, right? DR means designated router. Designated
Router.
router. Now, what is designated router? EIGRP doesn't give, I told you, routes. ESRP doesn't give any routes. It will share the topology.
Yes.
Meaning, who will give the whole topology?
Right.
See, even I will say my link up down only. Even though I will not give the topology. LSA means what? My link is up or down only I will say. But there is one router designated to give the topology details. Full topology details. All topology. Like 50 of whole network map. Who will give? Everybody cannot give. First point. Everybody will not say. Then it will become a like EIGRP OSPF RIP only.
Yes.
So they will give only their directly connected links up down only. But who will give the whole topology detail? That router who is designated to give the who gives the full topology details. Who will give this?
Designated router.
This router is called designated router. For some reason, we lost that designated router failed. We have a BDR. Backup designated router. So backup DR. Understand? For example, I'll say this R2 is DR. R3 is
BDR.
DDR. Okay. Now I'll add a new router here. Now this new router need a full topology details. Whom it will ask?
It will ask R2.
Only R2. R2 will give. Not everyone it will ask. So DR, BDR. Understand what is DR, BDR? Next. How many tables EHRP maintains?
3.
What are they?
Neighboring table,
Neighbor table.
topology table, and route.
How many table OSPF maintains?
3.
Neighbor database.
Yes.
Neighbor
Database.
database.
Link state database.
Link state database. Then
Routing table.
so what will be there in neighbor database?
The information of the next connected router.
Neighbor details.
Neighbor database.
What will be there in neighbor database? What neighbor details will be there? Is router ID. You know who is the neighbor, router ID. All information will be there. Example. What is link state database? This is the roadmap. Whole topology, all topology will be there. Full topology. Right? What will be there in the routing table? O. O means what?
OSPF.
So what will be there? Best, only best routes. Understand these technologies? Now we are going to do the lab. Let us start. Written? Next we start the terminologies. LSA, area, SPF, algorithm, router ID, loopback interface and address, backbone area, area border router, ASBR, designated router, BDR, neighbor database, link state database, routing table. Right? Covered everything. Any doubt in this?
No.
Now this is the topology. Draw the diagram. Do this lab. First I'll show you single area, then I'll show you multi area. Done?
Yes.
Okay, let's start. So concept right out. First topology host name, IP address, serial, right? Routing protocols. In routing protocols, important is what? First, I'm going to create a start the OSPF protocol. What is the command? Router OSPF 1, process ID 1. Then network command. Network command, what it will do? Add the interfaces to the routing protocol. In the network command, we have two things here, extra two things. Not only directly network address will give, yes, plus wildcard mask and area details. Now this is single area. Single area means what? All interfaces are in area 0.
Area 0.
Then I will teach you how to change the router ID. Then what I will teach you what is passive interface. These are the concepts we are going to study first. During the second half I am leaving. Okay, I will go to some institutes and see that any classes are making. Any classes are coming, CCNA classes will be coming in your institute, your entire one, online classes.
They will be coming, sir, but somewhere will be giving all the details. They won't share details with you.
You just tell me anybody wants a CCNA class nearby your area,
Yes, sir.
right? You contact, no?
Yes, sir.
So I'll go and teach in the
Yes,
institute.
sir.
But still we get business here, we need to go outside also, no option
Yes.
for us. Just need to have some business. And Yogesh, you start sending mails for a demo. Mail or WhatsApp. Mail you send it, plus you remind me in WhatsApp also. So I will schedule my, because see now onwards daily I will go. Okay, morning I will come here, afternoon I will try to go some institutes. Right, I will explore all the possibilities I am going to explore now. I am not going to sit here. So anyhow today I am finishing routing. So next 1 or 2 weeks I am finished. So, okay, Mallikarjun,
Yes, sir.
next 2 weeks I am finishing the CCNA RMS. Okay, this week I am finishing routing. So next week I will finish that. 2 weeks I will finish. Then whenever you are ready, you tell me. We will start security.
Yes, sir.
Same way I will finish Samir also in 2 weeks. So this month I am finishing both of them. Then whenever they are ready, next class we can schedule. You can inform Yogesh can schedule.
Yes.
We'll start.
Yes.
First, tell me. Session number 23, right?
24.
24, huh?
Yes, sir.
Okay, tell me. Mallikarjun, how many devices?
2 routers, switch, 3 PCs.
2 routers, 1 switch, 3 pieces. Okay. Okay.
Router 1.
Right?
Yes.
Okay, ready. Next. Hmm.
Sending IP address from PC.
IP address, no host name.
Hosting.
Huh? Also there or is not there in this law? In the concept is there or not?
Yes, sir, it is. Yes. We have name also.
Where you are?
Outside we have name, we have to name that command.
No, host name is there or not? There, right? So we have to do host name. Don't skip host name. Host name is very, very important in real time.
Yes.
Here, okay, I am just giving, but real time, the how do you know you are in the right router?
Yes.
Using only the
Host name.
host name only. Otherwise, you don't know we are in which router in real time. Because you are going to do remotely access, right?
Yes.
So host name is only the one you know that. That's the first thing you have to be very clear on. Host name. Okay, next.
Next is IP address.
IP address. Tell me IP address. Yogesh. Yogesh will tell the IP addresses. Yes, PC1.
192.168.10.2. That's all. 192.168.10.2.
You need to tell me, you don't need to wait for me. You keep on telling. You close this your notebook, you tell me your notebook. Tell me, answer. Where you see this one? Tell me next one, PC2.
PC2 192.168.10.3.
Huh? Start.
/24.
Tell me, you don't need to wait for my configuration.
Subnet
You keep
mask.
on, I know the answer. I'm just expecting you to tell the answer. That's it.
Okay, default
I know all the IP addresses. You just tell me.
default gateway 192.168.10.1.
Okay, that's it. Next. PC3.
PC3 192.168.30.2. /24. Default gateway 192.168.30.4.
30 dot? Okay. Now R1 FA0/0, what is the IP address?
192.168.10.0.
10 dot?
0. 10.1.
Right? Next one. Interface FA0/0/0 IP address.
S0/0/0 192.168.20.1 /24.
Right.
R2
R2 serial tell me.
serial 192.168.20.2 /24.
Right. Next.
R2 interface FA0/0 192.168.30.1 /24.
Done?
Yes.
Now how do you verify the links are up or running? What is the command?
So interface.
Show IP interface. Both are up and running. Next, now I am going to configure. Next what?
Serial.
Serial, right? Serial. What is the command? Interface. Serial 0/0/0. Clock rate 64,000. Right? Serial type. Next.
And routing protocol.
Okay, routing protocol syntax. Now syntax you write down OSPF command syntax. In global mode, what do you give? Router OSPF 1, and you will go to which mode?
Router.
Other router mode, right?
Router.
Then network
Network.
directly connected network address, correct? No,
Yes, sir.
directly connected interface network address. Then here there is a difference. Wildcard mask.
Yes.
Let me put like this. Close this. Wildcard mask. Then area number.
That one is
One is process ID.
process ID.
Copyright on process ID. This syntax will not give command, real command. This will process ID. Real command will be like this. Now what is wildcard mask? Area number, you know, area 0. This interface belongs to area 0. So what is wildcard mask? Wildcard mask is wildcard mask equal to inverse of subnet mask. For example, subnet mask is 255.255.255.0. Convert this wildcard mask will be 0.0.0.0.255. Then what is meant by 0? Binary 0 equal to match and 1 equal to don't care. Binary 1 equal to don't care. So now I have one router. In that 5 interfaces are there. I'll make a small scenario so you will understand this. What is wildcard mask? Okay. One, 2, 3, 4, 5. Okay. Now this is first one is 10.1.1.0/24. Okay. This is not 0. It will be not 0 because it has to be 1. This is IP address, na? Network address is not 0. When you configure interface, what do you configure? IP address or network address?
IP address.
Huh? Yogesh?
IP address.
Dot 1. This is 2.1. Right? 3.1 or 3.1. 4.1, 5.1. Okay, now I am going to give the command network 10.1.1.0. Okay, this is directly connected network interface. Okay, I'll give the here FA0, FA1, S0. S1, serial 1, serial 2, right? Now network 10.1.1.0, I'll give 0.0.0.255, area 0, something like this. Now which interface will be added in OSPF? This command. Match first 3 octaves 0, You know, do like this. This 3. Last octet don't care. So tell me, if this 3 is coming in which?
FA0.
So only which interface will be added? Huh? Which interface will be added in the OSPF? Understanding or not, Yogesh? Huh? This command is going to help you to add the network command. What it will do?
Add the
Interface to OSPF. Now when you are adding the interface, I am going to give wildcard mask. Wildcard mask is going to match how many bits I am telling. I am telling first 24 bits you match. In this IP addressing, which interface is having, which IP address is having 10.1.1?
first
Name of the interface.
FA0.
So that FA0 will be added in OSPF. Understand? That's it. Now I give one more network command. You tell me which interface will be added. Network 10.1.1.0. Okay. Right? 0.255 dot. Sorry, 0.0. 255.255. Area 0. Now tell me which interface will be added. Yogesh. Now I am telling, boss, you just see only the first 2 16 bits. Means first 2 octets. 10.1 you match. Rest all next 2 octets don't care. 1 means don't care. You understand? You got my point here? 1 means what? Don't care. Now tell me which interface will be added.
All this cube FA1, S0, S1 and S2.
5 interfaces will be added. All 5, right? Are you understanding? So which one will be added? FA0, FA1.
S0.
One command will add all the 5 interfaces. One more command I'll give. Network. Yogi, this guy, Mallikarjun.
Yes, sir.
Network 10.1.1.1 0.0.0.0 area 0. Which interface will be added?
No, it's
Why?
there is no match.
Why there is no match?
Because
Tell me the IP address of FA0.
10.1.1.1.
All 32 bits has to exactly match.
Yes.
That interface will be added. Now tell me which interface is having 10.1.1.1.
FA0.
Then? Are you understanding?
Yes.
Which interface will be added?
FA0.
Now if I give here 5.1,
Exactly 5 out.
which interface?
S2.
Understand? This is the best practice. Best practice is exact IP address and 0.0.0.0. Best practice. Now generally what we do, we just give the inverse of subnet mask. Generally, but if you want to do the exactly security, full security you want, you can go for this. Anybody just connecting the net router, they will not be able to connect. But if you give like a 0.0.0.2, anybody with that, it will be able to connect. Understand, na?
Yes.
So this is the more secured. What is less secured? Totally not at all allowed is 0.0.0.0 255.255.255 areas. All interfaces. What it will do? It will add all the interfaces. Whatever you keep on adding, it will be added. Understand what is wildcard mask? This is called wildcard mask. What I am teaching here?
Wildcard.
Yes, this is wildcard mask. This is for security. This is basically developed for what?
Security.
Securing. Unnecessary others must not come and when you add a new interface, automatically that interface is getting OSPF connected. No, I don't want like that. Exactly. Only if this IP address is there, then only OSPF will be working on that. Best practice is this.
spectrum diagram.
Understood this? Okay, we'll configure now. Understand the syntax, right? Okay, let's start configure. R1. First, I'm going to give show IP route. Let me see which are the interfaces are directly connected. What are the network addresses? What is the command? Show IP route. Yeah. Two interfaces are connected, right? 10 dot and 20 dot. So I'm going to add that. So what is the command? Yogesh, tell me. You written that? You written the syntax and these diagrams? Written or not? Tell me.
Yes, sir.
Huh? Both of you written?
Yes.
Okay. So tell me syntax.
In global mode, router OSPF versus IP.
Command tell me.
Router OSPF
Hmm.
1.
Hmm.
Then network.
Hmm.
Directly connected interface network address.
Yeah. Mallikarjun, open the door and
Open.
open it. Okay. Now open. Okay. Hmm.
Directly connected interface network address.
Hmm.
What is
What is show IP route is showing?
192, 168 and 0.
Which interface you are adding now?
Password.
FA.
0/0.
And then
Then wildcard mask.
subnet mask is what? /24. So inverse is
0.0.0.
area, single area, right? So all are area 0. Whichever interface you are adding, all interfaces are area 0 now. Done. Next one. Done. Configure both. Okay. Next I'm going to teach and take R2. Right? Tell me. First we will do show IP route. So you see that first command is what? So we can see that what are the interfaces are directly connected, which interface. Okay, the first command. In configure terminal, command router OSPF 1. Right? Next one.
192.168.20.0.
This is the command. Huh?
Command network. 192.168.20.0.
You tell, I don't need to wait. You keep on telling.
0.
Don't wait me to type it, huh?
0.00.255. Then area.
Tell the command here. What is the command? Just area.
Area is no area.
No area.
0.
Now again tell me the command.
0.0.
Tell me the command.
Network 192.168.20.0. 0.0.0.255. The area is 0.
That's it. That is 0. Pass it. Alright. Now neighborship has to form. What has to form? Form. See. Who is the neighbor? Y20.1. R1, right? Here 30.1, right? Y20.1. R1 is 20.1. Y not 10.1. Why the router ID is 20.1? How router ID selection happens? In terminology I told you how router ID works. How router ID is automatically selected. Tell me the answer.
Highest of link.
In the two interfaces, which interface is the highest IP address? 10.1, 20.1, right? So 20.1 becomes the router ID. Same here, 20.2, 30.1. Which will become the router ID? Highest is 30. Understand how the router ID selection happens?
Yes.
Now, neighbor. Show IP, OSPF, neighbor. See, neighbor ID is what? I'm going to change the neighbor ID. How to change the router ID? How to change the router ID? Manually one command is there, right? Router ID 1.1.1.1. See, what is the router ID now? I want to change it to R1s. I'm giving enter. It is giving a message saying that please reload the router or clear the process. I'm going to clear the process. Copy. I'll go to privilege mode and I'll give this command. Clear the process. Yes. Now the neighborship went down. Again neighborship is forming. This time when neighborship forms, the neighbor ID will be what? Router ID will be. Understand neighbor how the router ID you have to configure? Automatically takes the highest IP address. If the loopback is configured, highest loopback address, right?
Yes.
Right?
It's manual.
And manually also we can add this using this command, router ID command. Clear on this? Next one. Next concept.
Passive interface.
Passive interface means what will happen? Now in R2 I'll start the debugging. You know what is debugging, right? You see the inside traffic. Debug IP OSPF EMS. Now what it will show you? Hello.
Hello.
Every 10 seconds it is going to give you hello. Hello. Like EHJP was sending, right?
Yes.
Hello, hello. Like the OSPF also says hello. Every 10 seconds it sends hello. These hello messages, right? I don't want to send this hello in fast Ethernet. Why I have to send hello in fast Ethernet in R1?
Yes.
Think, in R1 there is no OSPF devices are running. Right? In the topology, see this topology R1, no OSPF devices are running. But there also hello is going in R1. I want to stop that. That is called, I want to make that interface passive interface. Which interface?
Passive.
FA 0/0 in R1. How to do that? Go to the other router OSPF mode. OSPF, sorry. Right? Passive interface question mark. The moment I give passive interface question mark, what happens? What happens? It will give you default one command is there. Default means what? Suppress routing updates in all the interfaces. What did you do? Passive interface default. Enter. I suppressed it. Went down. Clear?
But it will be suppressing on all the
interfaces I stopped. Now nowhere it is going. Even serial also not going.
Yes.
Right? Now we'll see that what happens this side. This side it will wait for 26, right? It will wait for hold on timer. Remember what is hold on timer? The hold. It may come back, right?
Yes.
Wait for hello into 4. Hello 10 seconds. So 4 is 40 seconds. It will wait for 40 seconds. After that the R2 neighborship will fail. And it's called hold on timer. Remember?
Yes.
See, now it failed. Understand this?
Yes.
Now I am going to give only serial interface
Yes.
active. I am going to make only serial, all are passive. I will make only serial interface active. How to make that? No passive interface, serial 0/0. I am removing passive interface only for serial. That is the best practice. This is the best practice. Okay? Or you can give one by one interface, you can say passive interface, this passive interface. That is okay, but this is the best practice. Stop everything. Which one you want to allow? Allow only that. Enter. Now, moment I give this, backside you see, so many things will happen. So many things happen. stop this. How to stop that? No debug or on. I stop. Now, see, first it send a receive hello, then DBD, then DBD send, then state went to full. See that exchange, extract, init, not slave, master. So many things are happening. This is called a OSPF finite state machine. Write down this. What is this called? When neighborship is forming, OSPF is going for multiple states. (24) na? OSPF finite state machine. Now, okay, let us use one paint only here, easy for us. I am going to have two routers. I am going to configure OSPF in there. So, what is the command to configure OSPF? Mallikarjun?
Router OSPF.
Which mode?
In global mode.
In global mode, what is the command?
Router OSPF and process ID.
Tell me the command.
Router OSPF 1.
Then
we have to go to other routers.
Other router mode.
In that network.
Directing the network address and the wildcard mask and area number. Right? Okay, now I configure like this. I added this interface S0. Now this interface, what it will do first, we saw, right, what it is doing. It sends hello. What it send? Hello. Then it will get a reply hello. Receive hello. When you receive hello, you check 4 parameters. How many parameters here? 4 parameters. If 4 parameter matches, remember 1 parameter we saw?
Yes.
4 parameters match, then neighborship established. Not matches? No neighborship. One neighborship is formed. The first thing what I will do is, I'll ask you, who is master? Tell me, who is master? Master slave election. So, teacher student, who is master?
Teacher.
Father son, who is master?
Father.
Husband wife, who is master?
Wife.
You're eligible for marriage. Understood, no?
Yes.
So you are understood very well. So what is master is doing? Master means, I'll tell you a simple example. Husband wife example I'll tell you. Train is there, right? So engine is husband, track is wife. You understand? How much powerful you are, how much shout you shouting. Oh, like that. You can shout, right? Engine shouts, right? Oh, like that, right? Husband shouts. So how much shout you shout, how much powerful you can take, how many people you want with you. Your team building, team management, but where you will take them? Where our track goes. Understand? So the same way here, master decides what is the you have to do. First you do this, I do this, like that. The process is defined by master. That's it. Only he will, his role is, the master's role is what? To define the process. Okay, today this topic, tomorrow this topic. I am in class what I am doing? I am putting one process. This is the way I teach. So you have to follow that. When you teach to you, when you become a teacher, you are a student, what you will do? Same thing. You tell the student, this is the process we are going to follow.
Yes.
So if a student says, no, whatever I ask you teach me means, teaching will not happen. Samira. Samir. Tell me something. Okay. No, I am going outside afternoon. So what I will do, I will go to home. Okay. From home I will try to call you. Once I reach home, I'll reach home at, now I'm going outside. I'll have some visits. I'll finish the visits. Sales I told you, starting sales. So that visits I'll finish. After finishing the visits, I will go to home. Okay. Then from home I will give you a call to you. Huh? Okay, we'll try to have some class on that. Okay. Okay, bye. Now he is busy, so he's second half I try. We'll go home and take. Okay, so understand what is master-slave relationship? So master will say, first master sends. What master will send? For example, think R1 is master. Okay, now who is master?
R1.
So R2. So first master sends DBD. What is DBD? I know only Malabar BD. Correct? What is DBD? Ganesh BD I know. Database description. What is DBD?
Database
Descriptor. Database descriptor. And he will send back his DBD. Database
descriptor.
So what is this database description? Very simple. Database description means table of contents of database. Now instead of sending the whole book to you, Xerox, whole book Xerox to you, I will take Xerox of table of contents, first 5 pages.
Yes.
I'll send it to you first. You send your whatever book you have, right? Database you have. Send me the description of that. Don't send me the full book Xerox. I will see that, okay, these topics I know, I have, okay, only chapter 6, IPv6 I don't know. Can you just tell me that chapter 6, no? Can you give me the Xerox?
Yes.
I can ask you, right? That is called LSR, LSU. What do you call this?
LSR,
Link state request. LSR means what?
link state request,
Then you give.
link state update.
Okay, so I am going to give you LSR. I am going to ask you LSR, and I got you as LSU. Understand? LSR LSU. Then the table database is synchronized. We call full state. What state?
Full state.
Full state. This state is called the loading state. Okay, now this is the process. So you understand this process, right? Now I explain you the state machine. What is the topic I want to teach you now? OSPF finite state machine. Finite state machine. Now I'll write down 8 states are there. Total 8 states. 1 down. What's the first state? Down. Meaning, what will happen in this state? No hello is sent. When you give this command, see here, I'll show you. Show, what is the command? It's neighbor table. Show IP OSPF neighbor, right?
Yes.
What is the state here?
Full.
Now the state is down. No hello sent. The next state is attempt. Attempt means what will happen? It's attempting something. What is attempting?
Sending hello message.
Sending hello. That's it. It is attempting, but it's not receiving any hello. Send hello. Hello sent. Then third is next state. Third state is I am going to receive now, right? That is init. Init means initialization. Now the initialization started. I am started receiving hello. See, we know that where we stuck actually, you know. If you know the states, it is easy to troubleshoot. The state you go and see, no? Oh boss, I am not, I mean init state. I mean atom state means what? The other R2 is not sending hello. R2 is down.
Yes.
Understand? No. I am in init state means I am receiving hello, but the 4 parameter, 1 parameter is not matching.
Not matching. Yes.
Understand? So receive hello. If 4 parameter matches only, it will go to
It's going to initialize.
two-way state.
Yes. Two-way state.
So what is the meaning? 4 parameters match. Matched. And understand, it's very important for troubleshooting. Huh?
Yes.
If you don't understand this, you can't do troubleshooting. 4 parameters match and my router ID is added in hello message. See, when I am sending hello, like for example R2 is sending hello. R2 is sending hello. R2 is adding R1's router ID as neighbor. When I am sending hello, I say hello. My name is this 2.2.2.2. Right? My neighbor router ID is 2.2.2. My neighbors are 1.1.1, 7.7.7. So I added my in the neighbors. I added your. So you understand that we are in two-way now. How do you know that they accepted me? In the hello itself, in the neighbors list, my router ID also added. That is what state?
Two-way.
Now the exchange starts. What will happen now? We have to do exchange, right? DBD, then LSR, LSU, right? So fifth state is what? X start. What happens here? Master, slave, election. If it is stuck in X start state means what is the problem?
Master election of master.
Somewhere master slave is not happening. It is stuck in there. Master slave relationship. Then sixth state is exchange. Now the real exchange is going to happen. What will happen? First, what we exchange?
First LSR.
No. First what?
First
See there.
Neighbor.
Master slave done. Next what?
DPD, table of contents.
So master send DBD and slave sends DBD. Understand? Next what? Exchange happened. Now loading. What is happening?
Loading.
Now loading. What will happen? LSR,
LSU.
LSUs are exchanged. Actually here the exactly your database is building. Right? Understand what is happening here? Database is building in both sides. There is LSR, LSU. Next, finally, everything is done. Database synchronized means full state.
Full state.
Database synchronized. Understand this? Are you understanding this point?
Yes.
Okay, it's very important for troubleshooting part. Okay, now let us go to the presentation. Now I am going to teach you multi-area. Multi-area, same thing. Determine your own router ID, add the interfaces, send hello message, receive hello message, check 4 parameters are matching, master relationship, DBD is exchanged and reviewed, neighborship is synchronized. Right? Now first, router ID what will happen? Highest IP address, highest loopback address, or can you use router ID command? How to add interfaces? How do you add the interfaces to OSPF? By what command?
Network.
By network command, second step. Third step sends hello. We saw right, every 10 seconds it's getting hello.
Yes.
If you configure frame relay or some other non-broadcast networks, like WAN we cannot do broadcasting.
Yes.
Non-broadcast networks, there we will send 30 seconds. Okay, next is hello contains so many information. See, what are the information hello is sending?
Router ID, hello and dead timers, network
You see
mask,
that?
area ID, neighbors, router priority.
The neighbors, that neighbors it will add. I told you no, who is my neighbors? That is also sent in hello. Then password, DR, BDR address, then password, priority number, right? All are sent. In that, star symbols are there. What are star symbols are there?
Options: head, hello and dead timers, area ID, and authentication passwords are options.
This 4 is matches only. Understand?
Yes.
Then
These
neighborship
four-
will
neighborship.
form. See, it will check these 4 parameters.
Yes.
Then
Hello.
it sends hello. Then master slave relationship will happen. 6th stage. 7th stage, what happens? LSR LSU is sent. Finally, you get the
Yes.
neighborship synchronous. That's it. This is the 8th stage. Any doubt in this? You know, cost is very simple metric. 100 divided bandwidth Mbps.
Yes.
Right? That we saw, right? Okay. Next concept. Let us. Okay, this diagram I don't want to draw now. I'll just tell you. You try this in your home,
Yes.
and I'll help you on building this. Okay. Now I'll ask you one question to Mr. Yogesh. R2 FA0/0. What is the OSPF command? OSPF command. Mallikarjun, be ready for serial. R2 serial OSPF command. Be ready for that.
172.
Command here, not IP address I'm asking. Command. I'm not asking IP address.
Router OSPF 1
Yes, router OSPF 1. In which mode?
in global mode.
In global mode, router OSPF 1. Good.
Then we go to
Other router mode.
There network 172.30.0.2.
2.
This
What is the syntax? Tell me.
directly connected to the interface network array.
Network. What is the syntax? Tell me again.
Directly connected network interface.
Directly connected network interface.
Interface network.
Network what?
Network address.
Network address. Tell me. 30.2 is network address.
At 0.0.
Tell me the full command again.
Network 172.30.0.0.
Correct.
Then wildcard mask is 0.0.0.255.
Correct.
Area
Which area it belongs?
area 0.
Area 0. Now you tell me for serial interface.
In global mode, router OSPF 1, and we'll go to other router.
Yeah, other router mode. Yeah, yes, correct.
Network 172.30.10.0 and 0.0.0.255 area 10.
Area 10. Now R5 loopback 0. Yogesh.
R5 loop back.
L0. L0 is loopback 0. Loopback 0 interface.
Then we have 4
Loopback 0. L0.
L0. Okay. Under global mode, router OSPF 1. Then it will go to router OSPF 1. It will go to other router mode. Network 10.0.1/32. 32 means
You are saying
0.0.0.0.
area.
Area 10.
Okay. Understand? So this is the way you configure. This is multi area. What we are doing now? Beginning what we did is single area. The once you do it in ASBR, as I told you an example, I am acquiring one company. That company is having RIP. So what I will do here, I will go to R1 and I will distribute the routes. RIP routes to OSPF network. So this is the distribution. See, this is the command. I will show you. Simple command, one command. Distribute RIP metric 99. So what will happen now once I do this? This will have R1 will have O for same area, OIA for different areas, other areas. If I get this routes, this will come in what? OIA. And if it is coming from this side, RIP, what will be there? R. Now once you distribute this R's, R will not come to R2, R3, R4, R5. Rip routes will not come to OSPF routers, R2, R3. Only it will come because this side we configure rip. This side we configure OSPF. Two router protocols are running here. Understand this?
Yes.
In R1, serial is rip. Fast Ethernet is OSPF. So two routing protocols are running. So both routes will come here. But R2 is both are OSPF only. There is no RIP, right? So it will not get the RIP routes. I want to share the RIP routes to inside. Then only you can communicate with the brand, other company.
Okay.
That routes has to come to inside our network, right? So how to bring that? You do distribution here. When you do distribution here, like this, everywhere it will go, right? When it goes here, it will become like O, external route type 2. What will come? 2, external type 2, type 1, type 2, there are two types other, type 1, type 2. You can see E2. The R will come here, what? In what line, what will come? After you distribute, how it will come? OSPF, external route type 2. So how do you distribute it? Just this command. Go to R1 and say distribute RIP routes and give the metric value 99. Why 99? Because RIP metric and OSPF metric is different. RIP is 1 to 15. OSPF will go more than, more than that. OSPF is too much. It's bandwidth divided by bandwidth, no? It's too much. So we don't know how much it will give. So we need to put question mark there. Whatever range you give, that range, that metric value will come in the routes. Whatever you give here, 99 means 99, 20 means 20 will come there. Whatever you give, it will come there. But it has to be some logic has to be there. Understand? This is redistribution. Loopback, how to create? See. How to create the loopback interface? Then give the IP address. By default, no loopback interface. You have to create virtual. Loopback 0, loopback 1, loopback 2, loopback 3, like that. So go to the device R5 and type interface loopback 0. Then give the IP address. Then loopback interface created, IP address given to them. Then that interface to be added to OSPF.
Here, no shutdown command.
Not required. It's a virtual interface.
No, not required.
See, virtual interface by default will be up. If it is down, administrator you can give no shut. But this will be up. By default it will be up. Understand this? What is loopback interface? How to configure? What is redistribution? Where we use redistribution?
When two OSPF and
like that. Different
routing
protocols. Now I have two routes here. All this. See, R1 must have RIP routes also. Then only. That's why we're creating here some loopbacks and adding to RIP. So this will come like 130 will come what? R. The same 130 will become here E2. Understand? In R5 what we will get here? E2. So these things you try. So Monday, if you send me the mail, then any doubts in this, we will clear. We'll open that mail and we will troubleshoot that same your protocol. We will troubleshoot.
But to connect the RIP and OSPF, we need internet or internet.
That is, this is the RIP serial, no? This is internet. In real time, you cannot take a cable and connect to other branches, other company. You have to go through anywhere. WAN connection means this is your cable, this is your connecting in your building. This is LAN. You are taking a Cat5 cable and connecting to switch. From your switch, you are connecting to another routers. But these things are going through service provider only. Whenever I put a WAN, you cannot directly connect. This WAN connection means what? You have to go through service provider. There are three types of connections are there in WAN service provider. That is same network, same company means intranet. You have to tell them different company, same company. Understand or not?
Yes.
Clear on this? Any other doubts? Okay, now what you have to do? Your homework?
OSPF.
OSPF single area, OSPF multi area, IPv6. So this, how many labs are we are finishing now? 30? I'll show you. Follow the same number, easy for me to troubleshoot, okay?
Yes.
Same concept, same number you follow. It's easy for us to troubleshoot. Otherwise, I need to understand every time what concept you are doing.
Yes.
Okay, now we are finished up to
Yes,
34.
34.
All I covered,
Yes.
right? So I expect you to do that up to 34 and send it to me. Once, for example, multi-area something is not working or you have some doubt in how to configure it, right? You send me one multi-area, then I can recorrect it. I'll configure and show you
Yes.
on next classes. Clear on this?
Yes.
Any doubts?
No.
Okay. So we'll wind up today. $24, right? Huh? Take.